Test 14, lessons 1 through 70. Number 1 is from lesson 61, and it says a piece of fabric is in the shape of a square. The area measures 28 square inches. Find the length of one side of the fabric. So some important information is we know this is a square, and the area measures 28 square inches. So when you have a square, all sides are equal. So we have the length times the width gives us the area. And since these are both the same numbers, it's just x squared. And we know that that equals 28. So if we want to go back and find the original side length, we need to take the square root of that area. Now we know that 28 is not a perfect square, so we're just going to have to simplify this as much as we can. So we could break down 28 into its prime factors. So I know some of my students like to make a factor tree. So we could do 4 and 7, and then 2 and 2. So I like to go and rewrite the square root of 28 as its prime factors, 2 times 2 times 7. And then remember, only pairs of numbers can go outside the radical sign. So since we have two 2's, that means we can pull out a 2, but 7 is by itself and gets left inside the radical sign. And now we want to make sure we put the right unit. It was inches. And since we're just talking about one of the side lengths, it's not squared, it's just plain inches. So your final answer is 2 root 7 inches. Number 2 is from lesson 31, and it says Corinne runs at 6 miles per hour. What is her rate in miles per minute? So notice we're going from miles per hour to miles per minute. So we're going to need to use a unit multiplier. So we always start with what they gave us, and that's 6 miles per hour. So 6 miles per 1 hour. And now here comes our unit multiplier. We're trying to go from hours to minutes, so we want to make sure our hours cancel out. So since hours is on the bottom over here, we want it to be on the top over here so that they will cross cancel. And that means minutes will go on the bottom. And the unit multiplier is where we write the relationship between hours and minutes. We know 1 hour is equal to 60 minutes. And so our hours cancel, and we're left with just a multiplication problem. So in the numerators, we have 6 miles times 1, so that's just 6 miles. And then on the bottom, we have 1 times 60 minutes. So that's 60 minutes. Now we can reduce this. We can divide both 6 and 60 by 6, and we are left with 1 mile per 10 minutes. And that's your final answer. Number 3 is from lesson 69, and we need to simplify. So if you look, both of our letters under the radical sign are the same, so these are like terms. So that means we are able to combine the numbers that are out in front, this 3 minus 6. So I know, again, some of you guys like to go and add, so we change this to add the opposite. So we really have a 3 plus a negative 6. So that gives us a negative 3. And then our radical sign stays exactly the same. So negative 3 root AB. Number 4 is from lesson 7, and we just need to simplify using our order of operations. So remember, we need to follow PEMDAS, and that means we need to start with parentheses, exponents, multiplication, division, addition, subtraction. So first thing we want to do is start with our innermost parentheses. So that's there, 8 minus 2. So notice I'm rewriting everything. 8 minus 2, that's going to give us 6. And that's squared plus 4, and then close parenthesis. Next comes exponents. So we have to do this 6 squared. So again, I'm rewriting everything. That's 36 plus 4. And now we still need to finish everything within our parentheses before we move on to anything else. So I need to do this 36 plus 4. So we still have this 3 minus 4 on the outside. But now 36 plus 4 is 40. Now this next step is where I see a lot of students make a mistake. They want to do the 3 minus 4 first. But you have to remember this 4 is being multiplied by the 40, and multiplication trumps subtraction. So you need to first do 3 minus 4 times 40 is 160. And now you can do the subtraction. And if you don't like that subtraction sign, remember you can always add the opposite. And you can see that it's really a 3 plus a negative 160. So we're left with negative 157. So on these order of operations, even though it might take a little longer, make sure you write out every single step each time so that you don't get lost and you don't actually miss something or go out of order. Super important, especially on a test, to take your time and do the extra work. Number 5 is from lesson 32, and they just want us to simplify this. So the biggest problem I see is we have this negative 2 exponent. Remember, we don't like to have negative exponents. And we can make that positive by just moving it. If it's in the numerator, move it to the denominator and vice versa. So in this case, we're going to move this whole thing down to the bottom, and it'll make it an a to the positive 2. So this now becomes a to the positive 2, and then we still have this b4 over here. We didn't have to move that. And so all that's left up at top is 1. Don't forget that you have that placeholder 1 up there. Number 6 is from lesson 58, and they want us to simplify. So it looks like a basic FOIL problem. So remember FOIL, I'm going to rewrite this real fast though. FOIL is first, outside, inside, last. So I just want to make this a little bit bigger. So we have our first. So the first 2 in each binomial, so 2x times negative 3x is negative 6x squared. Then outside, 2x times 3, so we have plus 6x. And then we have inside, so negative 2 times negative 3x, and that'll give us a positive 6x. And then last, negative 2 times positive 3, and that will be negative 6. Now we go through and look to see if we can combine anything. And we can right here. These are both like terms. So I'm going to rewrite this as negative 6x squared plus 12x minus 6. And that's your final answer. Number 7 is from lesson 36. It says a street light cast a shadow 36.4 feet long. A child who is 3 feet tall cast a shadow 5.2 feet long. The triangle drawn with the street light and its shadow is similar to the triangle drawn with the child and her shadow. How tall is the light? Since we know these two triangles are similar, we know that the side lengths are proportional, and we can set up a proportion. So I'm going to set it up as the child's height over the child's shadow height or length equals the light post light, which we don't know, so that's an x, over the light's shadow. And now at this point, we solve it just like any other proportion, and we're going to cross multiply. So we have 5.2 times x, so that's 5.2x equals 3 times 36.4. and that is 109.2. And now, just like any other problem, when you get x by itself, so we're going to divide both sides by this 5.2. And we should get x equals 21. And we had to remember our units, that was feet. So the street light is 21 feet tall. Number 8 from lesson 65 says determine whether the lines are parallel. So if you recall, we know two lines are parallel if their slopes are the same. In addition, I know it's not asking for this, but we know lines are perpendicular if their slopes are opposite reciprocals. But in this case, we're just doing parallel. So we need to compare their slopes. Now on this first one, we can easily see that the slope is 2/5. On this one right here, it's a little bit harder to tell because it's not in slope-intercept form. So the first thing we're going to have to do is move this into slope-intercept form by solving for y. So first thing I'm going to do is add this 2x to the other side. And that leaves me with 5y over here equals 2x plus 30. Now I'm going to divide by 5, and I divide everything by 5 over here. And I am left with y equals 2/5 x plus 6. Now it doesn't matter that the y-intercepts are the same. All we care is that, notice, their slopes are exactly the same. So therefore, yes, these are parallel. Number 9 is from lesson 55, and they want us to solve and graph this inequality. So just like an equation, we want to solve for our variable. So that means I need to get rid of this -6. So the opposite is to add 6 to both sides. We're left with x is greater than or equal to -2 plus 6. That's going to give us a +4. And if I go graph this, put 0 there, 1, 2, 3, here's our 4. And notice it's greater than or equal to, so that's going to be a closed circle. And we want all the numbers that are greater than 4. So all the numbers greater than 4 are going to be going to the right. Number 10 is from lesson 70, and we need to solve and graph this inequality. So if you notice, -x over 3, it's being divided by 3. So in order to undo that, I'm going to multiply both sides by 3. So you could multiply both sides by -3, or you could wait and do the negative with the x. I like to go ahead and get the negative done with, so I'm going to multiply both sides by -3. So this -3 and this -3 cancel. I'm left with x. And over here, 2 times -3 is -6. But notice, since I multiplied by a negative number, I have to flip my sign. That's super important. If you forget to flip your sign, it'll mess up the entire problem. And then next, we have to graph it. So I have my 0 here. -6 will be down here. And it's just an open circle this time. And notice I want x is greater than that number, so all the numbers bigger than it. So it's going to be going to the right. Number 11, Nick is typing a research paper on the computer. His typing speed is inversely related to his typing time. If he is typing at 45 words per minute, it will take him 4 hours to type his paper. How long will it take him if he types 30 words per minute? So I'm going to show you all 2 ways to do this one. The first one is using the inverse operation formula, which is y equals k over x. So if we go back and look, it says speed is inversely related to time. So I always know the first thing they mention is my y. So speed is my y, and time is my x. So they first give us 45 words per minute and 4 hours. So there's our time, our speed, and our time. So we can plug those in and solve for k first. So speed is 45, so I'm plugging that into my y, equals k, and then this is 4. And In order to get k by itself, I multiply both sides by 4. So those cancel, and I'm left with k equals 180. So now that we know our k, we can use that and plug it into a second problem in order to find how long or the time it will take him if he types 30 words per minute. So again, this 30 words per minute is his speed, so that goes into our y in our problem. So we have 30 equals, now we know k is 180, but this time we're trying to find the time, so we're trying to find our x. So first I need to get rid of the 180 divided by x, so I multiply both sides by x. Those cancel, and we're left with 30x equals 180. Divide both sides by 30, and we get x equals 6. So 6 hours is how long it would take him. So that is one way to do this problem. There is another way that I am also going to show you. So with inverse operation, you can also set up a problem using x1, y1 equals x2 times y2. So all this is you take your first xy pair, which was 45 and 4, that's our first one. So we will plug in 4 for x and 45 for y. And again, we're multiplying, so it really doesn't matter which order you put those two numbers in. And this equals our second set. We want to find his time when he is typing 30 words per minute. Again, these are being multiplied, so I could have written it 30 times x too. So we have 4 times 45 is 180 equals x times 30, which is 30x. We divide by 30, divide by 30, and x equals 6 hours. I personally think this method is a lot faster, but both of them, as you can see, give the same answer, so you just do what you're comfortable with. Number 12 is from lesson 40. A square photograph has a side length of 5n centimeters. So if we have a square, we know all the sides are the same, so length and width are both 5n. What is the area of the photograph? So this is basically just 5n times 5n, or 5n squared. Either way, you're going to get 25n squared, and it was centimeters, and this is area, so it's going to be centimeters squared. Don't forget to put your right unit there. So that's our final answer, 25n squared centimeters squared. Solve the system of equations by elimination. Now remember, with elimination, you're trying to cancel out either the x's or the y's first. So that means they need to be lined up, so both equations need to be written in the same order. If you look, our first one, we have x and then y and then our constant, but on the bottom we have y equals x plus 9. So I'm going to rearrange these. It doesn't really matter which one you arrange, but I think I'm going to rearrange this bottom one so that it's in the same format as the top one, which means I need to move this 3x over to the left so I have my x and my y's all on one side. So I'm going to do that by, let me rewrite it first so it's a little bit bigger. I'm going to subtract 3x, and then notice how in the first one you have your x and then your y, so I'm going to rewrite it exactly like that. So negative 3x plus 3y equals 9. So now they're both in the same form. So I'm going to erase this, and I'm going to rewrite the other equation right on top of it. So we have this 6x minus 4y equals negative 8. And as you can see right now, if we were to add these, 6 plus a negative 3x, those aren't going to cancel out. Neither will the negative 4 plus 3y. So we need to manipulate one of the problems so that they will cancel, so that either the x or the y's are complete opposites of each other. So I think I'm going to change the bottom problem and try to cancel out my x's first. So if this is a positive 6x, I need a negative 6x on the bottom in order for them to be opposites and cancel. So I'm going to multiply this whole bottom thing by a positive 2, because that will give me negative 6x plus 6y equals 18. So don't forget, you have to multiply that 2 by everything. So I'm no longer working with this equation, I'm working with this top and this bottom one. And we're going to combine them. So we have 6x plus a negative 6x. Well, those cancel, so those are gone, and that's exactly what we wanted. Then we have a negative 4y plus 6y. That's a positive 2y equals, and then we have a negative 8 plus a positive 18, and that will be a positive 10. And now we can solve for y by dividing both sides by 2, and y equals 5. So now we figured out what our y is. So if we have our answer up here, we know y is 5. However, we still don't know what x is. So I'm going to erase this, and we take any one of our original two problems and we plug in 5 for y and solve for x. It doesn't matter which one you choose, so I'm just going to choose maybe this top one. So we have 6x minus 4. For the y, I'm going to plug in 5 equals negative 8. So we have 6x minus 20 equals negative 8. I'm going to add 20 to both sides. We're left with 6x equals 12. Divide both sides by 6, and you get x equals 2. And that's your final answer, and you can check this by taking this xy pair and plugging them into both of these equations and making sure that they work. I'll do one as an example. Let's do the first. Let's check the first one. So if we had 6 and we plug in 2 minus 4, plug in 5 equals negative 8. We have 12 minus 20 equals negative 8. And 12 minus 20 is a negative 8, so that worked. And then on the test, you'd want to do the same thing for the second equation too. Number 14 is from lesson 41. It says a boat travels at a constant speed as shown in the table. What is the rate of change? Well, we know that time is our x, distance is our y, time is almost always x, and we know that we're going to be writing the speed it goes in miles per hour, so y comes first. And these are all basically points. So we just need to find the slope. So if time is our x and distance is our y, that first point is 2, 70. And the second one is 4, 140. I could have chosen any 2 points, but I just decided to be easy and just use the first 2. Now to find the slope, remember we find the difference in our y's, so I'm going to choose to start with 140 minus 70. And since I chose this y first, I need to choose this x, find the difference in our x's. So we're left with 70 over 2, which is 35, and it is miles per hour. Don't forget your unit. And that's the slope or the rate of change. Number 15 from lesson 44, determine the slope of the line that contains these points, 2, 4, and 3, negative 3. So very similar to the one we just did. We find the difference in our y's. So I'll start with this y this time and do 4 minus, and then this y is a negative 3. all over, since I chose this 4, I need to choose this x first, 2 minus 3. Now on the top, we know that if we change this to an addition sign, we add the opposite. So that's really 4 plus 3, which is 7. And down on the bottom with the x's, we can add the opposite or add a line, change the sign. So we have 2 plus a negative 3. So that is going to give us a negative 1. So if we simplify, our slope is negative 7. Number 16 is from lesson 47, and it says a supermarket marks down the price of a $3 loaf of bread by 15%. What is the discount and the new price? So you have to find two things here. So first we need to find the discount. We just need to find what is 15% of $3. So we have $3, and whenever trying to find the percent of a whole, we're multiplying. However, we need to change 15% into a decimal. We just do that by moving the decimal over 2 places, so it's 0.15. And now we just solve. So we have 0, 0, 15. Our placeholder, 0, 0, 3. And that gives us 4,500. However, we have 4 decimal places. So there's our decimal point. And remember, this is money, so we would say our discount is 45 cents. Now we have to find the new price. So if this is a discount, we're taking that discount off. We're subtracting it. So we're going to subtract 45 cents from $3. So we'll borrow. And we are left with $2.55 as our new price. So you should have 2 answers for this problem. Number 17 is from lesson 54. Make a box and whisker plot to display the data of student heights in inches in a math class. So remember, to do a box and whisker plot, we first need to put all of these numbers in order from least to greatest. So I'm going to do that real fast. Okay, so I have rewritten all of the numbers in order from least to greatest. And the first thing we need to do is find the median. So if we count inwards from outward of both sides, we know that our median is 65. So that's our median. We also need to find our lower quartile and upper quartile, or quartile 1 and quartile 2. So to find the quartile 1, we find the median of our lower data, and that would be 63. And to find the upper quartile, we find the median of the data above the median, and it looks like that would be 71. And we know the bottom numbers are our lower extreme and upper extreme. So now let's go and plot this on a box and whisker plot. So I'll put my number line here. I'm going to start with 57, and I'll just write down the odd numbers. Okay, so I made my number line. Now I'm going to go draw a line above 65 because that's my median. I'm also going to draw a line above 63 because that is my lower quartile. And then 71 is my upper quartile. And I make a box out of these 3 numbers. And then I put a dot, these are like the whiskers, on my lower and upper extremes. Oops, it wasn't 75, it was 76. And then we connect those. So there's the box and whisker plot. So that was the first part of the question. The second part was, half of the students are between which heights? We know that 50% of the data falls in between the lower quartile and the upper quartile. So if 50% of our data is in between those, we would say that half the students are between 63 inches and 71 inches. Number 18, what is the probability of rolling either 2 identical numbers or rolling a sum of 6 using 2 number cubes each labeled 1 through 6? So there is a chart you could write down, or you could just kind of think about it. Let's take one at a time. So let's look at the probability of rolling two identical numbers. You could roll a 1 and a 1, a 2 and a 2, a 3 and a 3, 4 and 4, 5 and 5, 6 and 6. So the probability of getting a doubles when you're rolling two number cubes is 6. And since there's 6 options for each roll, 6 times 6 is 36. So there are a total of 36 options you could get when you roll two number cubes. So the first probability is 6 over 36. Now let's find the second one, rolling a sum of 6. So I always like to start with 1. What if we first rolled the number 1? We would have to roll a 5 on the second cube in order to get a sum of 6. And then I flip that. You could also roll a 5 first and then a 1. Now let's move on to 2. If I rolled a 2 first, I would have to get a 4. And then again, flip those. And then 3, I would have to get another 3. And then we can't go back there because then we just go right back to the 4. So the probability of getting a 6 is 1, 2, 3, 4, 5, 5 out of 36. So we would add these together, 6 out of 36 plus 5 out of 36. However, notice that two of these probabilities we counted twice. This 3, 3 over here and the 3, 3 over there. So we don't want to count them twice. So we need to make sure we subtract one of those out of there. So now we can add and subtract all these together. So 6 plus 5 is 11, but minus 1 is 10 out of 36. We can divide both of these by 2, and that would give us 5 over 18. And that is your probability. Number 19 is from Investigation 7, but I know it's been in other lessons too. So it says identify the constant of variation if y equals 6 and x equals 3, given that y varies directly with x. Then write the equation of variation. So y varies directly with x. We know that formula is y equals kx. So we first start with these two numbers. So y is 6 equals k times x, so k times 3. If we divide both sides by 3, we get k equals 2. So that's our constant of variation. Now to write the equation of variation, remember we never put anything in for our y or x, we just plug in what our k is. And that is our equation. Number 20 says solve the system of equations below. So we could do a substitution or elimination. And since this first one is already solved for y, I would probably just use substitution and plug this y into this y right here. So we have 4x minus 10, and instead of putting y, I'm going to plug in this whole thing because it's saying y equals that. So 2/5 x minus 2 equals 20. Now let's solve for x. We have 4x minus 10 times 2/5. That is going to become 4x. And then negative 10 times negative 2 is positive 20 equals 20. So now let's simplify. 4x minus 4x. Well, those are going to cancel, so we're left with 20 equals 20. So you might be wondering what to do at this point. Well, it looks like since 20 does equal 20, this is going to be all real numbers. So I suspect that these must be the exact same lines. So I'm actually going to go back just to verify this and see if they are the same line by putting them both in the same format. So notice the first one is in slope-intercept form. I'm going to rewrite this second problem in slope-intercept form and see if they're the same thing. So I'm going to subtract 4x, We have negative 10y equals negative 4x plus 20. Divide everything by negative 10. And we get y equals 2/5, positive 2/5, because it's a negative 4 and negative 10, minus 2. Notice these are the exact same lines. Therefore, anything you plug in for x and y is going to be a solution for both of those. So your answer would be infinite number of solutions. And that is the end of test 14.